Good old terminology and definitions. But if we understand these terms, then concepts like tap conductor protection and motor protection will start to make more sense. We'll start to see how pieces of equipment and their conductors can actually be adequately protected, even though at first glance, circuit breaker or fuse doesn't seem quite right. Now, three of these are defined in the NEC, but short circuit is not. Well, let's just start with overcurrent. We'll break apart the word. Too much current. Whenever we have a situation where we have more current than a piece of equipment is rated for, or than the ampacity of a particular conductor, we have an overcurrent situation. And the definition goes on to tell me that these overcurrents can result from any of these three. Now, some devices are designed to protect from all three. Other devices might just protect from one or two aspects of this. And sometimes we'll use multiple devices together to provide the full protection. Now, overload. Again, we look at the word. Too much load. Or I could say too many loads on a circuit. If on a 20-amp circuit in my kitchen, I plug in, let's say, 6 or 7 toasters, well, that's going to be too many loads. After a little while, that breaker is going to trip. We have an overloaded circuit. Or I could have a piece of equipment drawing too much current. Perhaps I've got a motor that I'm working too hard, and I've got to ease up on it. Or sometimes if we have too high of a voltage, too low of a voltage, depending on the type of equipment, that can result in too much current flow as well. But one thing I want to say about overloads is that the current is flowing in the proper pathway. There's just too much. By proper pathway, I mean that the current is going down the hot, through the load, and back to neutral. Back and forward, it is AC. Or in a multi-phase situation, it's going back and forward on the appropriate conductors in the intended way. Now, this definition goes on to tell me that if the excess current continues for too long, it can cause damage or dangerous overheating. But there are safe overloads, ones that last just a few seconds and a few minutes, or sometimes longer, depending on the intended characteristics of the devices involved. And there's an info note under this definition that addresses that issue. But the final sentence under overload says that a fault, such as a short circuit or a ground fault, is not an overload. So what's the main distinction between overload and these faults? Well, I'm going to say that these fault currents are not flowing in the intended pathway, they are flowing in a wrong pathway. Here the current is taking a shortcut. Think of driving down the road, and instead of going all the way down to the light and waiting to turn right, you just decide, I'm going to cut through the gas station, the parking lot, whatever's there. The current is doing the same thing. Instead of going through the load and back, it's just taking a shortcut. It can be a line to line, or maybe line to line to line in a three-phase system, or line to neutral. And how much resistance would there be there? Often there's very little resistance. Therefore, how much current? Loads of current. Now, we could also have a hot to the ground. Now, whenever the ground is involved, we call it a ground fault. So it's still a short circuit, still taking the wrong pathway. So you'll often see ground fault as a subcategory of a short circuit. And a lot of current can flow there as well. You want that device to open right away. But then, could we also have neutral to ground? Yeah, that'll open a ground fault device. But if you look at the definition for ground fault, it says that it is an unintentional pathway between the hot and the ground. When I first read that, I was confused. I said, wait a minute, why not neutral to ground? And then I thought about it. Is this hot connected to this ground? their pathway. The load is pathway, which is electrically connected. And although this fault may not cause an excess of current to flow, it causes current to flow in a potentially dangerous pathway, so it will open the ground fault device and stop the circuit from operating. So, what are the main differences then between my overloads and these short circuits? I mentioned proper pathway, wrong pathway. But also, let's think that an overload, it often exceeds the rated current as much as 4 or 6 times, maybe more. But it exceeds the current for a period of time when the device will open. But a short circuit often greatly exceeds the rated current. So these pieces of equipment are designed to distinguish between overloads and short circuits. For some of them, generally overloads, they'll allow a little extra current for a little while and then open the circuit before things get too hot. But for others, generally short circuits, they'll open right away because the current can be so high that it can do damage almost instantaneously. So, I hope this helps you better understand equipment and conductor protection, especially when overcurrent devices seem a little off from what we learned